Hi ladies, in this video we're going to go through some questions from 8F, looking at percentage change and applications. So in number patterns, we've looked at a common ratio, but we also need to look at that in terms of percentage change. So it's a little bit harder. So I thought I'll do a video just to help. So hopefully we'll get working out on the right-hand side, and I've got the questions on the left-hand side. Now, with your general rule, we have Tn is equal to A times R to the power of n minus 1. So you need to know what n, A, and R all mean. So n is the term number. A is your first term, T1. And R is your common ratio. Now, when you're looking at percentage change, you need to remember that you have to calculate R. So your percentage change is, if we're doing a percentage decrease, we calculate R by doing 1 minus R over 100. And percentage increase, R is equal to 1 plus R over 100, where R is your percentage. Okay, so if you were, losing weight at 1% per day, that would be your R. Your R would be equal to 1, or maybe you've put money into a bank account and you're earning interest at 5% per year, so that would be 5 over 100. So R is just the percentage given to you. All right, so for question 1, I want to use pink. So 1A, it is state corrected 2 decimal places the first 4 terms in each of these geometric sequences for the changes given. So for 1A, we start at 100, so T1 is equal to 100, and decreases, so your percentage decrease, and R is equal to 5. Okay, so state whether it's increasing or decreasing and what R is, what your percentage is. So that's capital R. So that means our value of lowercase r, using this rule, 1 minus 5 over 100. Now you could just leave it like that if you want, or if you did that on your calculator, you would get 0.95. Now, when you think about it, if we're multiplying something by 1, it doesn't change. Okay, so you need to remember that. If you're multiplying it by 1 or 100%, it doesn't change. Now, if we were less than 1, it's going down. Okay, and we looked at that in a previous lesson when we were looking at geometric sequences. So if R was less than 1 or between 0 and 1, you're going down. And if R is greater than 1, so we're greater than 100%, then you're going up. Okay, so we've got that information. We can do the first 4 terms on the calculator. So remember, calculator is our friend. So first term is 100, so we press 100 equals, and then we multiply. So we're using this rule up here. So A, your first term, times R. So you can either type in 1 minus 5 over 100, which is the same as typing in 0.95. So I think it's a good idea to leave it like this, just in case you make an error. And you can just press enter. So our second term, so we've already got the first term. So T1 is 100, T2 is 95. Now, the thing is, when you keep doing this, you're going to get lots of decimal places. So if you're in exact mode, just press Control Enter to get your approximate. So 90.25. And T4. Okay, press Enter again. And I think it said to 2 decimal places, so I'll just do it to 2 decimal places. And then T5, press Enter again. Oh, I only had to do the first 4, didn't I? I did 4 iterations, but first 4. Okay, so we did the first 4 terms, T1, T2, T3, T4. Okay, and you can see it's decreasing. So we're starting at 100 and it's going down 5% each time. Okay, let's do one that is increasing. So let's do 1B. So identifying what we have. So T1, again, is 100. We're doing a percentage increase this time. And our R value is 20. So we have to calculate little r. So our common ratio, 1, because it's an increase, we're adding this time. Remember before we were subtracting. 1 plus 20 over 100. Now that is equal to 1.2, but you can just do that on your calculator. Okay, so let's get the calculator. Your first term, 100, press Enter. And then we multiply by r, so 1 plus 20 over 100. And I should get 120. Okay, so T1, we've already done, but I'll write it again. T1 is 100. T2 is 120. T3, so I just press Enter again. 144. And then T4, press Enter again. Oops. Now, if you get a fraction, just highlight it, press Enter, and then Control Enter. So 172.8. Now, if you want to get off doing fractions, just go to Menu, Doc Settings and Status Document Settings, and just change from Auto to Approximate, and that'll put all your answers in decimals. Okay, so because I teach a lot of other classes, I like it in exact mode, but if you just want to do it in decimals all the time, just change it to approximate. Okay, so let's move on to question 2. Tom purchases his car for $30,000 and expects it to depreciate in value by 15% each year. Depreciate, just want to underline the word depreciate, means it decreases in price. Okay, and when you think about you get a car, most cars go down in price unless you've got, a very old car that is very valuable. So sometimes they appreciate. Okay, so question 2, what will the value of the car be after 12 years? So let's identify everything. So our value of A, remember our initial value, which is also T1, is 30,000. That's what we start off with. We are going down, so we're doing a percentage decrease. And R is equal to 15. So that means we have to calculate lowercase r. So R is 1, because it's decreased, 1 minus 15 over 100. And you can do that on your calculator. You'll get 0.85. So your general rule, which we use for any geometric sequence, which I wrote up the top. I might just scroll instead of writing it again because we're running out of room. Okay, there it is in pink. Okay, so we're just substituting in for N, A, and R. Okay, so N is what term we want. So we want 12 years. Okay, so we're going to write T12. Actually, I'm just thinking if it's after 12 years, it should be T13. I'm just going to check what the textbook wants. Yeah, that's my bad. Sorry, I should have recognized that before. So we're doing it after 12 years. So because T1 is our starting value, which is 30,000, it's going to be 13. So 1 plus 12 gives you 13. So we want to know T13. Okay, so T13 is equal to A, our starting value, so 30,000, times R, 0.85, to the power of n minus 1. So 13 minus 1 is 12. And then you can just put that into your calculator. So 30,000 times, oh, very windy, 0.85 to the power of 12. So the car is not going to be worth much at all. So 4,267.25. So most of you will be getting a car soon, and you'd probably get a second-hand car. So, after 12 years, his car is worth a lot less. But when you think about it, you got a lot of years worth out of that car. All right, so question 3 and 4, I might just set those questions up for you over here. So Kathy invested, sorry, I knew that was going to happen. Question 4. Kathy invested $60,000, so T1 equals 60,000. It grows, so if it's growing, it's increasing. So we're doing a percentage increase. So R is equal to 8. What will her investment be worth at the start of the 7th year? So T1 is the first year, T2 is your second year. So we want the 7th year. It's not after 7 years, it's in the 7th year where T1 is your first year. Okay, so T7, just putting everything into our rule. So that's your value of A. I didn't write it here. So A is also 60,000 times R. Now, you can write it in. So 1 minus, plus, because it's a percentage increase. Now, I often see questions where you have to actually put it in like this. So just remember this is little r, okay, and we substitute big R there for 8 to the power of n minus 7, so it's going to be to the power of 6. Okay, and then you just put that into your calculator. Why did I write question 4? That was question 3, sorry. Now we're getting on to question 4. Just rewrite 3 there. Okay, so question 4. The population of 2,000 in a small country town is expected to decrease by 10% each year. So we've got T1, so our starting value is 2,000. Remember that is also A. A is the same as T1. And it's percentage decrease. And the percentage it's decreasing is 10. State the first term and the common ratio. Okay, so your first term we've already recognized. So A is 2,000. R, because it is a decrease, it's 1 minus 10 over 100, which is 0.9. Give the rule. So at the start of each year, so we want, so this is, just give me 1 sec. Okay, so I just wanted to make sure it wasn't a recurrence relation or a rule. So what we're basically doing for question B, it says give the rule for the start of each year. So we're leaving everything in terms of n. So we don't know what n is. So we're saying, all right, Tn is equal to A, our starting value, 2000, times R, which is 0.9, to the power of n minus 1. Okay, so what we do is we just need to then substitute in the value of n. So for question C, what will the population be at the start of the 10th year? We're just letting n equal 10. So we're doing, oh gosh, T10, it's very windy, 2000. I don't know whether you can hear things banging on behind me. And 10 minus 1 is 9. And then you just put that into your calculator. Question D, after how many years will the population be less than 500? So you can, girls, just do solve on your calculator, or you can just keep doing pressing enter on your calculator. So we want to know n when the term is 500. So 2000 times 0.9 n minus 1. So you can use solve on your calculator. Oops, sorry, that's not what we wanted. All these blue icons all look the same. Okay, so you can do solve 500 equals 2000 times 0.9 to the power of n minus 1. So you can use n, you don't have to use x, comma n. Okay, so n is equal to 14.15. Now it does ask, let me just scroll up. It has when it's less than 500. If we do 14, it's not going to quite be there yet, so you have to round up. So 15 years. Now, if you wanted to on your calculator, you could keep doing your recurrence relation. So we're starting with 2000. Okay, and we're multiplying by 0.9 each time. Okay, so we've had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So when n is equal to 15, actually, n is equal to 15, but that is after 14 years. Okay, so in the first year, we're at 2000. So n being 15 is 14 years after 14 years. All right, I'm going to leave it there. Bye, girls.